22 chapters down, 2 to go. The worst is behind us. We have 2 more pairs of procedures to learn. We've got procedures for 2 groups of means, and they're separated into 2 different chapters. The chapter 23 is when we have 2 independent groups that we're comparing. So this is going to look very much like the 2 sample or 2 proportion p intervals and tests that we did back in chapter 21. And then chapter 24 is paired means. Sometimes we have data that come from 2 groups that are connected in some sort of way, and those have to be dealt with slightly differently. So here we go. Chapter 23, day 1, we're comparing 2 independent means. So we're still in quantitative world. The word averages or means should be floating around in there somewhere, and that's how we know that we're still in T world, we're still in quantitative world. So chapter 22, we dealt with a single sample mean. We met the T model. We're still going to continue to use the T model, which looks a lot like the normal model with some adjustments, one of which is this degrees of freedom thing that's still a bit of a mystery, but there is a video coming soon after spring break that digs into just a little bit of insight into what degrees of freedom really are. For today, we're going to skip to some big ideas. First of which is going from a 1 sample test to a 2 sample test. What are the differences? We're not actually going to get into tests today. We're going to get into tests next week after fall break or spring break. And for today, we're going to deal with the confidence intervals. So we'll just take a quick look-see at this, and then we'll move on. So in 1 sample world, which we just finished, we started with a null hypothesis that we had the same mean that's always been the mean before. So the average number of people who can pass a test is 205. The average test score is 160. The mean weight of the cows is 2,500 pounds. Some average that we start knowing, some status quo, versus mu that has not changed. So the null, we normally have an equal to a number, a quantity, and then in the alternative we have a greater than or less than or a not equal to that same quantity. The numbers should be the same in both of those. We had an improved formula for standard error that used the standard deviation S of the sample that was taken over the square root of the sample size. And then the new and improved t-score, observed mean minus the expected mean over that standard error formula. So this is what we just quizzed over yesterday. So then we put that beside the business for 2 samples, and it looks way messier, but it really isn't that much different than we did with proportions. So instead of talking about p's, we're talking about mu's. Remember, we're making claims, assumptions about the population mean. So we should be using Greek letters. Now in percentage world, in proportions world, we always said in our null that the difference in the 2 p's was equal to 0. In mean world, it's almost always still equal to 0. But it could be something different. It could be that the difference between the 2 groups was 20 pounds in the past, and now we want to know if it's bigger than, smaller than, or not equal to 20 pounds. So we could have a number other than 0 here. So this is actually delta. This is the Greek letter delta, which means the change or the difference in the 2 means, sub-0, which indicates that it's the difference assumed in the null hypothesis. Again, most of the time this is a 0. Occasionally it could be a different number. If it were a different number, you would be told what that number is. You stick the number in there, and then you use the same number in your alternative with a not equal to, a less than, or a greater than. I think I've only ever seen, since I've been teaching stats, one problem where that delta was not a 0. and it was a 2. The difference in your samples is exactly like the difference in your p-hats looked in Proportion World. And if we want to know the standard error, which we will need to compute a t-score when we do a hypothesis test, we need a formula for means. So this formula actually comes from the Blue Book. I'm going to lay this aside just for a minute. In your Blue Book on page 2, you have all your sampling, distribution, and inference formulas. We used all these P formulas in Unit 5. And then we moved on to the means in Unit 6. And we just finished with the section, Chapter 22, on the means and the standard errors for a single mean. So this is the formula we were using in the last chapter. So we're going to graduate now to 2 separate populations. And the mean of the differences is the difference of the means. So instead of p's, we have mu's. And the standard error that we use in our hypothesis test and in our confidence interval is this formula, which is basically that Pythagorean theorem for random variables rule that we learned back in chapter 16 that's been rewritten for 2 groups of standard deviations. All you really care about is looking the formula up, sticking numbers in. You'll notice this is a lot less complicated than the formulas that we had for p-hats and q-hats and n's up here. Look at those formulas. We had 2 different ones, one for confidence intervals and one when we pulled our proportions for hypothesis tests. And then we have refined it into something much, much neater, much less cumbersome for means. So that's the good news. The worst formulas are behind us. This one is much simpler to use. You'll also notice that there is not a formula for pulling 2 groups. We never pull groups, ever. In quantitative world, we have one formula that works all the time. So no pulling involved. Same formula works for both confidence intervals and hypothesis testing. So that's really good news. Everything else on this page, linear regression and chi-squared, that is the stuff that has been kind of knocked off the end of the course for this year because of schools being out for the coronavirus. And so we won't really need to worry about these on the AP exam this year because those last 2 units have not been included. So we'll put that out of the way and go back to here. This is the next page. We have now some interval information, and this is what we want to dig into today. So we'll go back to the t-score and other messy business on that last slide next Monday when we do the second day's notes. We're not going to worry about that for today because we're not doing a test today. So one last little page of crazy before we actually dig into a question. When we had a 1 sample t interval in chapter 22, we started with the mean of the sample, added or subtracted the critical value t star for a particular number of degrees of freedom, and those degrees of freedom were 1 less than the sample size, multiplied by that standard error formula. So this is the one that we just quizzed over. Now we're moving to 2 samples, and in 2 sample world, instead of a single mean, we have the difference of 2 means. Looks exactly like the difference of p-hats that we did in the last unit. We have t star with degrees of freedom. That's a little more complicated this time. And then that standard error formula for 2 means that was in the Blue Book that we're just going to substitute numbers into and let the numbers get crunched. Now here's the catch. In the last chapter for t star with a particular number of degrees of freedom, you had to use your inverse t command on your calculator to find that number. It's not that simple for 2 samples because degrees of freedom is not that simple for 2 samples. So here's the good news. We don't actually have to find that number. We don't have to actually put a numerical value in for t star. We can simply write t star and a number for degrees of freedom and be done with it. So that's going to save us a little bit of work in this unit. And the reason for that is because degrees of freedom are super duper ugly for 2 samples. The calculator will actually just do it for us. It'll calculate the degrees of freedom for us like it's always done before. and then we'll just copy it down. And so we're not actually required to substitute the value for T-star because of that on the AP exam. I'm going to give you one super quick look at the formula, and then you'll never want to see it again. So in the textbook, chapter 23, on page 607, there is at the very bottom of the page, and I can't get my, okay, I'm going to try not to like make you sick here. I'm going to adjust a little bit. At the very bottom of the page, on page 607, is in a footnote the formula for degrees of freedom. This is it. I've never used it. I never intend to use it. You won't need it either. That's your one look at the degrees of freedom formula. For one sample, it was n-1. Done. Finished. Beautiful. In this chapter, it's crazy. And even the authors say, are you sorry you looked? It doesn't give you a whole number if you're using a table, if you're using technology, yada, yada, yada. We don't ever want to look at this again. It's not in the formula book because nobody intends to use it. The calculator will compute it for us, and that's all we're going to care about. So that's the only time we're going to look at that mess. So we can go back to the less messy work at hand. All right, let's actually do an interval. So we'll go straight to a problem. We already know the structure. We already know how to check conditions. That's nothing new. So we can hit the ground running on this one. A factory hiring people to work on an assembly line gives job applicants a test of manual agility. How good are you with your hands? This test counts how many strangely shaped pegs the applicant can fit into matching holes in a 1 minute period. Kind of like that little game, the little game Perfection. I used to have one of those where you push down the board and you have to put all the little shapes in the holes before it explodes in your face. I don't know if you remember that game or not, but it used to be one of my favorites because it had a bunch of geometric shapes that went in the holes. Anyway, so they use this test to see if people can do the job or not. The table below summarizes the data by gender of the job applicant, and we're going to assume that all conditions necessary for inference are met. Now that's beautiful. Those are beautiful words, because if they tell me that conditions have been met, I don't have to check them, and it's beautiful. I don't write them down. So let's just review just verbally what we're not going to write down. We're not going to write down that we have a random sample of subjects, male and female, who take the test. They've already checked to make sure that's true. Woohoo! We don't have to check to see that each subject in the male and female groups, each of those subjects had independent numbers of pegs that they could put into the holes in 1 minute. We don't have to check that. It's already been checked. We don't have to check to make sure we have a sample size of at least 30 for each group. Turns out we do. We got 50 males and 50 females. That's plenty large enough sample to guarantee nearly normal sampling distributions. There is a fourth condition that we always have to check when we have two groups, and that is to see if the two groups are independent. So I'd have to assume that the number of pegs males can put in is independent of number of pegs that females can put in, and I would need to make that assumption if I were writing up the assumptions and conditions. Fortunately, I don't have to write any of that down. It's already been checked, which means I can skip straight to the mechanics. Mechanics are the easy part. Okay, so number of subjects, that's N. So I'm going to do some labels. So N sub M for number of males is 50. N sub F is my number of females. Okay, mean number of pegs placed. Now those are the ones that were actually placed by the samples. So the men on average could place 19.39 pegs in a minute. So that would be the Y bar of the men. And the women could place on average 17.91. So that's Y bar for the females. Again, we have multiple groups. We need to use subgroups. 1s and 2s will work, but something a little easier to keep up with, like M's and F's, would be a better choice. Standard deviations of each of those two groups. So S is for standard deviation. So S of M would be the standard deviation of the males sampled, and S of F would be the standard deviation of the females that are sampled. So once I have that nailed down, then I'm ready to start sticking some numbers in a formula. So I have a formula back on that last slide. I'm going to pull it back up, open it back up so that I can hopefully see both things at the same time. So here's my formula, and I want to start with the difference of the two means. Now I have to decide if I want to do males minus females or females minus males, and it's just a choice that you make. Just because my head likes to work from left to right, I'm going to do males minus females because that's the order they're in the table, and I'm going to be less likely to switch some things up if I do it in that order. So how you make that choice is a personal decision. So the difference of the two Y bars. Okay, so Y bar for males is 19.39 minus the Y bar for females is 17.91. It's exactly like we did when we found the difference of the two proportions in the earlier unit. We just have not percentages anymore. Okay, and then we'll do plus or minus T star with a particular number of degrees of freedom. Okay, so plus or minus T star. Now, normally I would put a number there, but with two groups, I do not have to actually put the number there. The only thing that I'm going to be expected to communicate is what that actual degrees of freedom is as a subscript. I don't know that number yet. I'm going to wait and let the calculator tell me what it is when I run my actual confidence interval. Times, okay, and then I need the formula for the standard error. So I'm going to not pull my paper back down because it's just getting harder to look at. So we need the square root of, and then we do the first group. So I'm doing the first group is males. Now this is all about spread, so the only numbers I'm going to need here are my standard errors and my sample sizes. So the first fraction says take S sub 1 squared over N sub 1. So 1 is the males. So I need the standard deviation of the males, 2.52, square it, because I'm doing basically the Pythagorean theorem, over the sample size, 50. Now that doesn't get squared. Be really careful that you don't try to square everything. So this is basically S over the square root of N squared. So we're taking our old formula for an individual sample and we're squaring the top and the bottom. Plus, and we do the same thing for females. So standard deviation of the females, 3.39, square it over the sample size of 50. So pretty clean, not a lot of stuff going on there. Much, much less messy than working with proportions. Now the rest of the work is just doing the computation. I need an actual confidence interval, and in order to get that, I'm going to let the calculator crunch the numbers. So, like with a single sample in the last chapter, we have options when we use our calculator. We can put data in a spreadsheet and then reference that data to run our confidence interval. So you'll see one problem like that in the homework. Or we can be given summary statistics like this and just put the stats in and let the calculator run it. So let's go to menu, statistics number 6, and confidence intervals number 6. And what is the name of this one going to be? Oh, I didn't have to check conditions, but I still should name the procedure. So let's create a 2 sample, a little bit off my screen there, T interval. We should name the procedure even if we don't have to check conditions. That's typically part of your point value on the AP exam. So it should be a habit. And I'll be reminded when I go here, because if I have to look up the name of it, that reminds me that I need to write down the name of it. I do have a 2 sample T interval. It's option number 4, so we're going to go with that one. again, I'm prompted, do I want data or do I want a stats? I don't have the actual raw data. I don't have the data for these 50 males, and I don't have the data for these 50 females. I only have the summary of the data. So I'm going to change this to the summary stats. Click on OK. And it's going to prompt me for all of the information that's in this table. So males was my group 1. I want to make sure I maintain the same order here. The X bar is the mean, same thing as Y bar, 19.39. And standard deviation for males is 2.52. Sample size is 50. And then repeat that for the females. So 17.91 is the mean, 3.39 is the standard deviation, 50 is the sample size, and then I'm asked last of all for a level of confidence. Were we asked to do a specific level of confidence on this question? Well, actually I haven't even gotten to the question yet. The question's on the next page. So if I flip to the next page, it says find a 95% confidence interval for the difference in the mean number of pegs that could be placed by men and women. Okay, so here's where my work's actually supposed to go. I'm a little bit ahead of the game, but since I'm already writing it down, I'm just going to continue the work here, and we'll just arrow it over to the other page. So we need to do 95% confident. That's the default setting. It's changeable if you want. And then we'll tab one more time and notice that there is an option there that we were not expecting. It's asking us if we want to pool or not. We didn't get that option when we did 2 sample P's. It just did what it wanted to do. So here's the deal. If we have to pool, we won't get the option. The only time we ever pull anything is in a 2 proportion Z test. Okay, when we ran a 2 proportion Z test, it didn't ask us if we wanted to pool or not because we have to. We don't get the option. When you get the option, you're always going to say no. So we never, ever, 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 ever pool. If we're asked to pool, we say no and we move on. The only time we pool is when they don't ask us if we want to, which means we just have to remember to do it. It's a little bit quirky, a little bit frustrating, but it is what it is. Okay, so now I have more stuff to look at than I can even put on the screen. I have all the summary statistics spit back out at me so I can kind of double check, make sure I typed everything in correctly. And what I really want is what's up above that. So the first thing I see going up the page is the degrees of freedom are about 90.4858 blah blah blah. We'll say about 90.5. Okay. There's not a real clear association between that and the 2 sample sizes of 50 and 50 that we started with, because there's that really nasty formula that governs it that we don't want to fool with. We're just going to write it down. You can either write it as a subscript here, or if you'd prefer, you could go anywhere off to the side and you could write your degrees of freedom in a separate place, but they have to be in your mechanics somewhere. So either write it separately or write it as a subscript. You don't have to have both. If you think this is a little messy to look at, then put it over here to the side. It'll be just fine. And last but not least, we need our bounds. So the lower bound is 0.29-ish, and the upper bound is 2.67-ish. Now remember, these are numbers of pegs. So this is quantitative data. These are not percentages. Do not interpret these as percentages. They just aren't. Okay? So we've had all we need from the calculator. And I'm going to transfer over to this other page that confidence interval before I move it out of the way. Here we go. There's our confidence interval. The work is on the previous page. It doesn't matter as long as it's on there somewhere. Now, just a side note, alternative notation, if you decide you want to use inequality notation, you've got to be super duper careful what your symbol is here, because we are, oh wait, that's still not even right. males minus mean of females. See, I made a really big mess of that. Okay, this is how I fix my messes. I'd mark it out and I do it over. So this is the difference in the average that all men and average that all women can, number of pegs they can put in 1 minute. So in terms of notation, it's pretty messy if you use an inequality, because we want to say the difference in the average number of pegs, men minus women, is between 0.29 pegs and 2.67 pegs. That's just hard to look at, hard to write correctly the first try if you're not being careful. The safe route is to use the interval notation. Okay, so what I haven't done yet is write a conclusion. I didn't even leave myself a lot of room because that would have required some forethought. So let's squeeze a conclusion in here. Conclusion should always have the level of confidence embedded. That's the way you should start. Some of us didn't do a good job of that on the last test. We need to practice it. We are 95% confident that men can place an average, make sure the word average or the word mean is in there somewhere, of between 0.29 pegs and 2.67 pegs more than women in 1 minute. You really want to communicate that you're talking about all men and all women. There should be a comparison word in here somewhere. That's where the more comes in, and you're comparing the two groups. So make sure both groups are mentioned in context and there's a comparison word to compare the two groups. The word average or mean must be in there somewhere. So we're not talking about individual men, we're not talking about individual women. We're talking about groups of men and women and what they average. One last question about this problem. What does the interval suggest about any gender-based difference in manual agility? Well, the difference in men and women is positive. The lower bound, upper bound, all positive. 0 is lower than this, or 0 is not included. This indicates that men tend to have a higher average. They tend to be faster. So what does this suggest? Well, it suggests, doesn't prove it, just for the record, but it does suggest that men tend to be able to place more pegs than women. In other words, they appear to be faster. Since the entire interval is positive. Now, one last connection before we wrap this problem up. If we were to run a hypothesis test dealing with this same situation, we might start with a hypothesis that says men and women can place an equal number of pegs on average. So the difference is 0. Difference of men minus women equals 0 would be our null hypothesis. Men and women are the same. And then we would probably have an alternative hypothesis that said they're not the same. Mean of the men minus mean of the women is not equal to 0, indicating that one group is faster or more agile manually than the other group. If we were to run that test, we should get, if we do a 5% alpha level, which is that's your extreme ends of your T-curve if you take a 95% confidence interval. The outer 5% would be reject zone. So if we had a p-value at the end of the test that's lower than 5%, we would reject the null, which is rejecting the fact that the two groups are equal. And that would be evidence that the two groups are not the same. Men and women are different in terms of manual agility. So that would agree with what we have here. If we ran the test at a 5% alpha level, we should get a conclusion that agrees with the conclusion that we drew here. The conclusion we drew here is that men and women aren't the same. If we ran the test, we would reject the null that men and women are equal, and we would still draw that same conclusion that they're not the same. So if we have an alpha level that coordinates with this confidence level, then we should get the same conclusion whether we do the interval or we run the test. There will be a couple of homework questions that ask you some general questions about that idea, and then we'll dig into that a little bit more as we do more questions later. Okay, and so that leaves us with one hypothesis test to run. So this is going to be the work that we start the next time. There isn't a homework assignment in your PowerPoint this time, so let me jot it down here on page. Now I'm going to have to change my screen. Page 625. We're going to do numbers 1, 3, 15, and 17 for homework. There will be a homework quiz over that on Schoology as usual. Again, my answers are uploaded in Schoology in your Unit 6 folder, so check your work as you should be doing. We've got one more day of notes when we get back from break over hypothesis tests, plus an extra day of practice. And then we'll have a quiz and start the last chapter. It's going to go by pretty quickly. And whether we go back to school physically or we continue to work online, as soon as we finish with that last quiz and test over it, we'll be ready to start reviewing the entire content to get ready for AP exam. And there will be more materials on AP Central by then for us to practice with, so we can kind of get accustomed to the nature of what that test is going to look like. So I hope you guys enjoy your spring break. Have a nice little time off. If you're behind, it would be a good time to get some things caught up. But it looks like most of you are staying caught up pretty well, at least from my view in Schoology. So good job that way, and hope you enjoy some time off.